Hey everybody, it's Mr. Delgado here. We're going to be working on our first unit of the year, which is going to be our Smart Start. So I will have attached these Cornell notes already outlined for you guys. Your guys' job is to add original thinking along with our notes on the sides and add at least 2 questions in the question margins. And I want a good solid summary that's using math terminology that I use in this video to explain, or to summarize our notes. Okay, so make sure you have a good summary and your good questions. I will be looking at your guys' notes and giving you guys a grade for them. So please take good notes. Okay, so our essential question for today is, what is the order of operations and how is it used to solve math problems? Well, to solve the order of operations is the way we solve math problems. I've seen so many different types of like Facebook posts where it looks something like this, right? It'll go like 5 plus 7 times 1 plus, let's say, 4 divided by 2, right? And you'll go into the comment section and you'll see like 40 different answers, right? Because people don't know the simplest part of math, which is the order of operations. How we solve these problems and how we approach every problem, there's a standard set of ways to do it, right? We follow an order of operations. So we do things in a particular way for a reason. So if you guys can remember this, please excuse my dear Aunt Sally. You guys will be able to solve all of these types of problems, okay? So the P stands for parentheses, the E stands for exponents, the M and the D stand for multiplication and division. When we have multiple multiplication and divisions in a single problem, you make sure you work from left to right, just like you do with reading, right? And the same with addition and subtraction. You work from left to right. So if we're looking at this problem, right, we have multiplication and we have division. Well, the first multiplication problem we have is 7 times 1, right? So I'm going to solve this in a different color. 7 times 1 is 7. 4 divided by 2, that's the next thing, right? So this is getting multiplied. The next thing is division. 4 divided by 2 is 2, right? So now we've solved this part and we've solved this part, but we have addition here and we have addition here, right? 5 plus 7 is 12 plus 2 equals 14. So the correct answer is 14. Now, if we had just done it like everybody else, we would have got a way different answer. Let's just do it from left to right like some people do. 5 plus 7 equals, this is the wrong way. Repeat, this is the wrong way to do it. So 5 plus 7 is 12 times 1 is 12 plus 4 is 16 divided by 2 equals 8. So people would be like, oh, the answer is 8. Well, no, the answer is actually 14 because we do the order of operations. Okay, so here's an example. Okay, this is what you're actually going to see. You're not going to see too many problems like the first one, but you'll see more problems like the second one. Here's our example. Okay, so we're going to get started. 6 minus 3 plus 2 times 3 squared plus 3 plus 1. Okay, so we're working using PEMDAS, right? So we have parentheses here in the first step. So we're going to do parentheses first. Right, so we're going to solve these parentheses. 6 minus 3 equals 3. 2 times 3 equals 6. 3 plus 1 equals 4. So that's our next step, right? Then that's the next thing we're looking for. We're looking for exponents, right? So that's the second thing. Second is the exponents. Do we have any exponents? Yeah, we do. We have a 2 right here, right? So 6 squared, which is 6 times 6, is 36. So now we've got rid of our exponents. Now we have all addition, okay? And we do addition and subtraction from left to right. So we'll add 3 plus 36 first, and we get 39. Then we add 39 plus 4, and we get our final answer of 43. Okay, so that is our first part of our notes, just kind of reviewing PEMDAS. How are we going to apply it? Well, here's our second set of notes. How do I solve a one-step equation? Well, you use it using PEMDAS, right? And inverse operations. So when you solve an equation, your goal is to get the variable by itself on one side of the equal sign. In other words, you want to isolate the variable. Please remember, a variable is a letter that represents a number, right? It's a placeholder, really. So if I don't know, let's say 5 plus, I don't know a number, instead of putting a question mark, equals 10, well, that's kind of elementary, right? We don't want to use a question mark. We'll just use a variable. We'll say a. 5 plus a equals 10. Solve for a. Well, 5 plus something is going to equal 10. Well, we'd use inverse operations, right? Right now, we're adding 5. So an inverse operation of addition is subtraction, which is said right here. So we'd find out that, well, 5 plus 5 equals 10. So we'd be able to solve for variables. Now, problems that you guys will be facing in the very beginning are going to be as simple as this, but they get more and more complex throughout the year. So when you're working toward isolating variables, you need to use inverse operations, which means inverse is just a fancy way of saying opposite. Okay, so our inverse operations are listed right here. So whenever you guys see a problem and you need to isolate a variable, you're going to be using inverse operations. So the opposite or inverse operation of addition is subtraction. The inverse operation of subtraction is addition. And the same for multiplication and division. Those guys are inverses of one another. So whatever operation is performed, you also have, this is a key. This is important. Whatever operation is performed must be performed on both sides of the equation. Okay? You can't just subtract it from one side and call it done. You got to do it on both sides. Okay, so here's example 1. Solve for x. So our original equation is x minus 4 equals negative 2. Well, the inverse of subtraction is addition. So we added 4. We did it to one side of the equal sign, so we had to do it to the other. So negative 4 plus 4 equals 0. And that cancels out. So we get our x by ourselves, and we get x equals 2. Okay. Final example for our notes for today. We have a multiplication problem. 4y equals 20. You're probably wondering, where is the multiplication? There is no multiplication symbol there. Well, if you look really, really close, you'll see a tiny little red dot there. You see it? Yeah. Anytime there's a variable right next to a number, it's implying that there is multiplication going on there. Okay, so we have to do the opposite of multiplication, which is division. So we divide by 4. 4 divided by 4 equals 1. And then we did it to one side, so we have to do it to the other side. 20 divided by 4 equals 5. Okay, so that is using inverse operations, and we talked about PEMDAS in the notes page above this one. So your guys' job is to complete our homework for the week. Make sure you have at least 2 questions and a solid summary here. Okay, solid summary. I will be collecting in Google Classroom your notes and your homework sheet. All right, guys, that's it. I'll see you guys next time.